right, everyone. Now, in this lesson, which is 2.03, we're going to look at what happens if you have a variable on both sides of the equal sign. So everything we've done so far, the variables were either on the left-hand side of the equal sign or the right-hand side of the equal sign. So what we're doing here is you'll notice I've got an n on the left and the right-hand side of the equal sign. Now, you've got a whole bunch of different ways to approach this problem. What you want to do conceptually is you want to get all the n's on one side of the equal sign and all the constant numbers on the other side, and then you can solve it. You can start that four different ways. You can subtract 4n from both sides, you can subtract 7 from both sides, you can subtract 2n from both sides, you can subtract 10 from both sides. Those will all work. Now, what I like to do is think ahead a little bit. For example, do I move the variable terms first or do I move the constants first? Well, just to be consistent, in my head, I always move the variable terms first. You don't have to do it that way. Do whatever works in your own head. And then, so I know I'm going to be moving one of the variable terms first. Now, do I move the 4n or the 2n? Well, I think ahead. See, if I subtract 4n from both sides, 2n minus 4n is going to give me a negative 2n. And maybe negatives are just another thing I got to worry about. So instead, I'm going to subtract 2n from both sides. 4n minus 2n is a positive 2n. And I'm not going to have that negative to worry about. So let me take you through the problem. My head says move a variable term first. So I'm going to subtract 2n from both sides. Okay, positive 2n and negative 2n, those cancel. And I have 4n, take away 2n, that's 2n. Bring down the plus 7 equals 10. All right, so notice my n term here is positive, and I don't have to worry about keeping track of negatives. Now it's just a standard two-step equation. To get rid of the plus 7, I subtract 7 on both sides. The positive 7 and negative 7 cancel. I have 2n equals 10 minus 7 is 3. Then divide both sides by 2, because a 2 in the numerator will cancel with a 2 in the denominator and leave just n. So n equals 3 over 2, which I will write as 1 and 1/2. Okay, pretty simple example, but let's take a look at another one just in case. Example, and we're going to do Oklahoma. So today's example are old musicals. And actually, the musical Oklahoma had an exclamation point after the title. So anyway, let's take a look at this one. I've got 6x plus 2 equals x plus 10. Now, think back to my discussion about how to start these problems. I talked about moving the variable first and doing it in a way that leaves a positive, okay? So, would I subtract 6x from both sides, or would I subtract x from both sides? Think ahead before I do it. Hopefully, you figured out that the way I approach these problems, and maybe it's different for you, is I'm going to subtract x from both sides. And I do that because 6x take away x is 5x. That's a positive number. And I have plus 2 equals positive and negative x's cancel, and I bring down the 10. So, subtract 2 from both sides. And I know that was right because the positive 2 and the negative 2 cancel. Bring down the 5x. 10 minus 2 is 8. Divide both sides by 5. And x equals 8/5, or 1 3/5. Okay? Now, notice both the answers had fractions in them. I don't want you guys to be afraid of fractions. Please get used to working with fractions. They are part of mathematics. You're not always going to get nice, neat, integer answers in life. Okay, so that was variable on both sides, but these are pretty straightforward. So let's jump into one that's a little more complicated, okay? And we'll do this one titled Singing in the Rain. A great musical with Gene Kelly and Debbie Reynolds. If you've never seen the movie, it's a great classic old movie. Your grandparents would love the fact that you'd seen it. So here we go. This is a long one. We've got 10 parenthesis x plus 4 parenthesis minus 4 times x minus 2 equals 3 times x plus 1 parenthesis plus 2 parenthesis x minus 3. Okay, now look, the complexity of the problems just jumped. We went from pretty standard variable on both sides to this beast of a problem. But you've got this. You can handle this. If you're looking at this, you're probably thinking, well, the first thing I want to do is distribute all those numbers. And that's exactly right. So we would take the 10 and distribute it. We would take the negative 4 and distribute it. We would take the 3 and distribute it. And we would take the 2 and distribute it. Now, I'm going to go back to this. Make sure when you distribute this, you're distributing a negative 4. All right? So let's write what we've got. We've got 10x plus 40 minus 4x plus 8, because negative 4 times negative 2 is a positive, equals 3x plus 3 plus 2x minus 6. Okay, so boom, we've got all this. Now what we want to do is, if you've got this kind of situation where you have variable terms on the same side of the equal sign, okay, you want to add those, plus you've got a 40 and an 8 that can be combined, and a 3 and a negative 6 that can be combined. So let's use the commutative property, get the like terms together. So we've got 10x minus 4x. Notice that the minus is coming with the 4x term, plus 40 plus 8 equals 3x plus 2x plus 3 minus 6. Now I've got all those like terms next to each other, so I can combine them. I don't think this time I'm going to use the reverse distributive property like I was doing before, because we all know that if I have 10x and I take away 4x, I have 6x. And if I have 40 plus 8, I have plus 48. Equals 3x's plus 2x's is 5x, and 3 take away 6 is negative 3. Okay, now this looks a lot like the problems that we had up here. So, for my way of thinking, I'm going to subtract x from both sides, because that's going to leave me a positive x over here. So subtract 5x from both sides. The 5x and the negative 5x cancel each other out. We have a single x plus 48 equals negative 3. Now I can move the 48 by subtracting 48 from both sides. Positive 48 and negative 48 cancel, and have x equals negative 51. So there's my solution on that one. Okay, so much more complex, but really well within your wheelhouse. You guys know how to do all these steps, okay? So don't be afraid of a problem just because it looks a little lengthy, okay? Now, let's take a look at another problem. Now I'm going to throw some fractions into it. So we'll set this page aside. We've now gone to page 2. And we're going to do another great musical, 7 Brides for 7 Brothers. Okay, great musical. And here's the problem. It is y over 12 plus 1 over 6 equals y over 2 minus 1 over 4. Okay, a couple ways to do this. One is to look at each side of the equal side individually and try and get common denominators. So we're going to start with that method. So my common denominator over here would be 12. So I'm going to keep the y over 12 plus 1 over 6. But 1 over 6 I'm going to multiply by 2 over 2, because that'll give me a 12 in the denominator. And on this side, my common denominator is going to be 4. So I need to multiply the y over 2 by 2 over 2. So I've got y over 2 times 2 over 2 minus 1/4. Now we've got some arithmetic to do. Y over 12 stays just the way it is, plus 1 times 2 is 2 over 6 times 2 is 12. Notice common denominator equals y times 2 is 2y over 2 times 2 is 4 minus 1 over 4. So now we've got those common denominators, and we can combine the numerators. So y plus 2 over 12. No, remember, when you're doing fractions and you're adding common denominators, you're adding them and they have common denominators. You don't actually add the denominators. It stays that way. Equals, and now we've got 2y minus 1 over 4. All right? Again, it's just a single 4. We're not subtracting. All right, so now, if you remember, there was something called cross multiplication. This is where it gets a little intense. I can take the lower denominator times the right numerator, multiply them together, and it will be equal to the numerator on the left side times the denominator on the right side. This is cross multiplication. So I've got 4 times y plus 2, 4 times y plus 2 equals, now we've got 12 times 2y minus 1. Okay, now we got to keep going. The problem is just kind of, we're whittling it down a little bit at a time, but we still have more distributive property to do. So I'm going to multiply both sides by 4 here and multiply both sides by 12 over on this side. So we've got 4y plus 8 equals 24y minus 12. Okay? I'm going to move the variables around, but notice this time, on all the previous problems, the variable terms have ended up on the left-hand side of the equal sign. This time they're going to end up on the right-hand side of the equal sign. So I'm going to subtract 4y, subtract 4y. And again, the reason I'm doing it is so that I end up with a positive 20y on this side. Okay, that's why. Notice it's positive, not negative. Okay, the 4y and negative y cancel. I'm sorry, the 4y and negative 4y cancel. I bring down the 8 equals, I've got the 20y minus 12. Okay, we're going to add 12 to both sides. And we've got 20 equals 20y. And if we divide both sides by 20, it should be pretty obvious that the answer is 1. So 1 equals y. And there's your solution. Okay? There is another way to do this problem that some of you may find a little bit easier. Let's look at the sum, if you will, of all the steps you had to do it this way. So I just want to show you a second way to do it you may find a little bit easier. So I'm going to bring the same problem down. Y over 12 plus 1 over 6 equals y over 2 minus 1 over 4. So same problem. We're going to put an or in here so you know it's a second way of doing it. Now, instead of looking at a common denominator on the left-hand side and a common denominator on the right-hand side, let's look at a common denominator that stretches all the way across the problem. 12, 6, 2, and 4 all go into 12. So 12 would be my common denominator. So what I'm going to do is I'm going to multiply the entire equation by 12. And I'm multiplying the entire equation, not just one side or the other. Watch what happens. 12 times y over 12. Well, think of that as 12 over 1. 12 in the numerator, 12 in the denominator cancel, and I'm left with just y. Plus 12 times 1, 6. Well, that's 12 times 1 over 6 is 2 equals 12 times y over 2. Well, 12y over 2 is 6y minus, and 12 times a fourth would be 3, but that's a negative 3 because 12 times a fourth, okay? Now look, it only took us one step with this method to get to a pretty standard variable on both sides, whereas up here, look at all the steps it took for us to get to a pretty standard variable on both sides problem. All right, let's subtract y from both sides. So the y's cancel because one's positive and one's negative. So we have a 2. I don't know why I put the plus sign there, so just ignore that. equals 5y. 6y minus y is 5y minus 3. All right. Remember the whole point was to get a positive 5y, so I got that. Add 3 to both sides. 5 equals 5y. Divide by 5, divide by 5, and 1 equals y. So either way, you get to the same answer. But you decide, looking at the amount of work, which way seems easier to you. I'm not going to tell you how to do it. I want you to start figuring out what works best in your head. If you think that this more methodical step-by-step method works well with you, by all means do it. But if you see that this method works just as well, do it that way. You need to start thinking about what works in your head. All right, so there we go. There's your lesson on solving